Hi there. This is a realistic DevOps interview simulation focused on debugging Kubernetes systems under real production pressure. These questions are designed to test how you think when alerts are firing, users are impacted, and information is incomplete. Before listening to each answer, pause the video and explain what you would do out loud as if you were in a real interview. That's how you turn this into actual preparation instead of passive watching. If you want more long-form DevOps interview simulations like this, subscribe so you don't miss the next one. Let's start with a few warm-up questions. Tell me about a time you had to debug a Kubernetes issue during an incident. A strong answer would sound like this. We had an incident where error rates spiked right after a deployment. At first, it wasn't clear whether the issue was with Kubernetes or the application. I focused on stabilizing traffic first by slowing the rollout and reducing load. Once things were stable, I checked pod restarts, events, and recent config changes. It turned out a misconfigured environment variable caused the application to fail under load. The key was separating immediate mitigation from deeper investigation. Next question. How do you stay calm when debugging Kubernetes under pressure? A solid response would be, I rely on structure. Under pressure, it's easy to jump between theories, so I force myself to follow a clear order, check impact, confirm what's changing, and isolate one variable at a time. I also narrate my thinking to the team so we stay aligned and don't duplicate effort. That structure helps reduce panic and keeps debugging productive. Another one. Tell me about a time Kubernetes behaved in a way you didn't expect. A good answer might be, we once saw pods restarting even though the application logs looked fine. After digging deeper, we realized liveness probes were too aggressive and were killing pods during short startup spikes. Kubernetes was doing exactly what it was configured to do, but our assumptions were wrong. That incident taught us to be much more careful with health checks. Next question. How do you communicate progress during a Kubernetes incident? A strong response would be, I keep updates short and factual. I focus on what we know, what we're testing, and what the next checkpoint is. I avoid speculation, especially when leadership is listening. Clear communication reduces pressure and lets the team focus on solving the problem instead of reacting to noise. One more warm-up. What's a common mistake you see people make when debugging Kubernetes? A solid answer would be, a common mistake is treating Kubernetes as the problem too quickly. Often, Kubernetes is reacting to an application or configuration issue. If you blame the platform too early, you can miss the real cause and waste time changing the wrong thing. Let's move into technical and scenario-based questions. Users are reporting errors, but Kubernetes dashboards show everything as healthy. What's your first move? A strong answer would be, I trust user impact over dashboards. Kubernetes health usually means containers are running, not that the application is functioning correctly. I check application-level metrics, logs, and recent changes. Dashboards are a starting point, not a source of truth for user experience. Next scenario. A pod is restarting repeatedly. Walk me through your debugging process. A solid response would be, I start by identifying why the pod is restarting. I check events, exit codes, and restart counts to see whether it's crashing, failing probes, or being killed for resource reasons. Once I know what's triggering the restart, I decide whether it's safer to mitigate quickly or continue observing to gather more data. Another question. How do you decide whether to roll back a deployment during a Kubernetes incident? A strong answer would be, I look at timing and risk. If errors started immediately after a deployment and rollback is fast and safe, I lean toward rolling back to stabilize users. If the connection is unclear, I may pause the rollout and investigate further. Rollback is a tool, not a failure, and using it early can save a lot of time. Next scenario. Kubernetes keeps rescheduling pods, but the issue follows the pods, not the nodes. What does that tell you? A good explanation would be, that's a strong signal the problem is with the workload rather than the infrastructure. Kubernetes moving pods around helps eliminate node-specific issues. If the problem follows the pod, I focus on application configuration, dependencies, and resource behavior rather than cluster health. Another question: how do readiness and liveness probes complicate debugging under pressure? A strong response would be: probes are critical, but they can also create noise. A failing readiness probe might protect users, while a failing liveness probe can make things worse by restarting pods too aggressively. Under pressure, I'm careful not to disable probes blindly. Instead, I try to understand whether the probe reflects real health or is contributing to instability. Next scenario: when multiple things are failing at once, how do you decide where to focus? A solid answer would be: I prioritize based on user impact and reversibility. I focus first on actions that reduce blast radius and are easy to undo. I avoid making multiple changes at the same time because that makes it harder to understand cause and effect. Debugging under pressure is as much about restraint as it is about action. Another question: you're debugging an incident where pods are running, but requests are intermittently timing out. CPU and memory look fine at first glance. How do you approach this? A strong answer would be: I start by questioning the assumption that CPU and memory are the only constraints. I look at connection counts, thread pools, and downstream dependencies. Timeouts often come from saturation elsewhere, like exhausted database connections or slow external calls. I also compare successful and failed requests to see what's different. The goal is to understand whether the pod is actually overloaded in a way that basic metrics don't immediately show. Next scenario: you notice that Kubernetes events are filling up quickly during an incident. Some seem related, others look noisy. How do you use events effectively without getting overwhelmed? A solid response would be: I use events to build a rough timeline, not as a single source of truth. I scan for repeated patterns like eviction messages, probe failures, or scheduling delays. If events are noisy, I focus on the ones that align with the start of user impact. Events are useful for context, but I always correlate them with logs and metrics before drawing conclusions. Another question: a service is scaled up, but performance doesn't improve and errors continue. What does that tell you? A strong answer would be: that scaling alone isn't addressing the bottleneck. It suggests the problem may be downstream, like a shared dependency that doesn't scale, or an internal limit within the application. At that point, I stop scaling blindly and look at where requests are actually getting stuck. More pods won't help if they're all waiting on the same constrained resource. Next scenario: you suspect a configuration issue, but changes are risky during an active incident. How do you decide whether to change configuration or hold off? A thoughtful response would be: I weigh the blast radius and reversibility of the change. If a configuration change is small, well understood, and easy to roll back, I'm more comfortable making it. If it's complex or touches multiple components, I might hold off and look for a safer mitigation first. Under pressure, I prefer changes that reduce uncertainty rather than introduce new variables. Another question: how do you reason about Kubernetes or node-level issues when debugging application failures? A strong explanation would be: I look for signs that the node itself is under stress, like disk pressure, network issues, or frequent pod evictions. If multiple pods on the same node show strange behavior, that's a clue the issue isn't application-specific. I compare behavior across nodes to see if the problem is isolated or systemic. Node-level problems often show up as flaky application behavior. Next scenario: a rollout is paused because error rates increased, but the team is split on whether Kubernetes caused the issue or exposed it. How do you proceed? A solid answer would be: I focus on evidence rather than opinions. I compare behavior before and after the rollout, and I look for configuration or code changes that could explain the errors. Kubernetes often exposes issues faster because it enforces readiness, limits, and restarts. Whether it caused the issue or revealed it matters less than identifying what actually changed and why the system can't tolerate it. Final question for this section: when debugging under pressure, how do you avoid tunnel vision? A mature answer would be: I periodically step back and reassess assumptions. If I've been investigating one theory for too long without progress, I deliberately question it. I also listen carefully to signals from the system, even if they don't fit my initial hypothesis. Staying flexible and willing to change direction is critical when debugging complex systems under pressure. Let's move into the final part of this interview. These scenarios are intentionally uncomfortable. There isn't a clean answer, and that's the point. What I'm listening for is how you think when the system is unstable and the clock is working against you. Here's the first scenario. You're in a live incident. Users are reporting errors, pods are restarting, and autoscaling is already active. Metrics are noisy, and nothing is clearly red. Some engineers want to keep digging. Others want to make a bold change to force stability. How do you decide what to do next? A strong answer would sound like this. I slow the situation down mentally before making any big move. When signals are noisy, aggressive changes can make things worse. I first ask what action would most likely reduce user impact with the least risk. That might be pausing deployments, reducing traffic, or temporarily disabling a non-essential feature. I avoid making multiple changes at once. Once the system is calmer, I can reason more clearly about what's actually happening. Next scenario. A senior engineer suggests bypassing Kubernetes safeguards like readiness probes or restart limits to get things working. Time is tight, and leadership is pushing for results. How do you handle that? A thoughtful answer would be, I acknowledge the urgency, but I'm careful about removing safety mechanisms under pressure. Those safeguards exist to protect users and the system, even if they're inconvenient in the moment. If I consider bypassing one, it's only as a last resort, and with a clear understanding of the risk. I'd prefer to adjust probes or limits in a controlled way, rather than disabling them entirely. I also make sure the decision is visible and documented, so it doesn't quietly become the new normal. Another pressure scenario. You believe the issue is application-related, but Kubernetes behavior is making it harder to prove. Restarts and rescheduling keep masking the original failure. How do you proceed? A strong response would be, I look for ways to observe the failure without immediately triggering recovery. That might mean temporarily reducing restart aggressiveness or capturing logs and metrics right before failures occur. Kubernetes is great at keeping things running, but during debugging, too much automation can hide valuable signals. I try to create a window where I can see the system fail clearly without making it worse for users. Next scenario. An incident lasts longer than expected, and leadership starts asking why it's taking so long. You're still unsure of the root cause. How do you communicate and decide next steps? A mature answer would be, I'm honest about uncertainty. I explain what we've ruled out, what we're currently testing, and what decisions are pending. I avoid guessing or overpromising timelines. At the same time, I make sure we're doing something concrete to reduce impact, even if we don't fully understand the cause yet. Clear communication builds trust and buys time to make better decisions. Final pressure question. After the incident, someone says, Kubernetes made this harder to debug, while someone else says, Kubernetes saved us. How do you reflect on that? A strong answer would be, I see both as partially true. Kubernetes adds layers that can complicate debugging if you don't understand them well, but it also reduces blast radius and recovers from failures faster than most manual systems. I focus on what the incident taught us about our system design, observability, and assumptions. The platform isn't the enemy or the hero. It's a tool that reflects how well we've designed and operated our workloads. Take a moment now to reflect on this interview. Debugging Kubernetes under pressure isn't about memorizing commands or dashboards. It's about staying calm, questioning assumptions, and making decisions that reduce risk when information is incomplete. Think about which questions challenged you the most and where your instincts felt uncertain. Those are the areas worth practicing. Let me know in the comments which question you found the hardest and how you would have handled it. If you want more long-form DevOps interview simulations like this, subscribe so you don't miss the next one.